point, I've got all of the operations we can do with fractions, add, subtract, multiply, divide, and then simplifying and things like that. So in math, oh, sorry, I don't know what happened over here. In math, we always like to start with the definition, okay? So we define rational numbers to be any number that can be written, and this A over B should be over here. So that's, I don't know how that got moved, but somehow that got moved. So this should be A over B right here. And A is an integer and B is an integer. So any number, and remember the integers are things like 0, 1, 2, 3, and then their opposites, -1, -2, -3. So sometimes people think, if you think about a number like 5, is that a rational number? Well, it's not in that form, right?
Yeah.
But can we write it in that form?
Yeah, like if you do it over one.
Yeah. So since I can write it this way, it's a rational number. What about 5 over 0?
No, because it can't be zero, right? B can't
Right,
be zero.
right. B can't be 0. So this would be undefined, so not irrational. And then you probably remember the numerator is the number on top of the fraction bar, and the denominator is the number on the bottom of the fraction bar. So we use those words a lot. And then we have a bunch of examples here. Now, 0 is a rational number, right? Because I can put anything that I want in the
Yeah.
denominator. Doesn't matter, right?
Mm-hmm.
Make it negative, doesn't matter, it's still 0, right? So any denominator that I want. So that's what we mean when we're talking about, sorry, my mouse is not cooperating.
Okay.
Wants to keep jumping back onto my other screen. There we go. All right. Ugh. You know, these looked okay. I think it's because I'm using a second screen and I didn't test it out in this
Yeah,
form. So I apologize.
it's
So
okay.
this should, you know what? Let's just do, um, oh no, that's so weird. Nope, it doesn't even matter. Okay, I'm going to bring it back up again then because I don't really know what happened here. When I ran through it about an hour ago, everything was fine. Okay, so if A over B is a rational number, then we can write what we call equivalent fractions. And we use this to do certain operations, like especially if we're adding and we need a common denominator. So if I have some fraction like 3/4, then I can take any number over itself, maybe 5 over 5. And 5 over 5 is exactly 1. So I can rewrite this as 3 times 5 over 4 times 5, or 15 over 20ths.
Mhm.
And so as long as we follow something like that, then we say that those are equivalent fractions. So that's our next term, equivalent fractions. And then one of the main operations that we do is reducing a fraction, which is just to divide both the numerator and the denominator by the biggest number that will divide into both of them. And so one way of doing that, which we'll look at on the next screen, is to use what we learned a few sections back when we were talking about writing a number in lowest terms by finding these fraction trees and then finding the common denominators and dividing them out. So that's one way to do it, right? I can say 130 is 2 times 5 times 13 by using my little fraction tree. 455 is 5 times 7 times 13. And then I notice they both have a 5 and a 13. So I can divide numerator and denominator by 65. That's one way. In practice, though, there's two ways that I do it. And one way is if it's simple enough numbers. I'm going to go back to the other screen since this is looking so weird. So the way that I would do a problem like this one is I would just look at it and say, oh, you know what? 2 doesn't divide into either of them, does it?
Mm-mm.
But I noticed that 5 is going to divide in, right? Because you remember the rule for division by 5, what the number has to end with?
So then, like, oh, oh, wait, I don't remember that. Is it zero or five?
0 or 5, because if we count
Oh,
by
okay.
fives, we've got 5, 10,
Yeah, oh
15,
yeah.
20, so they
They
always end
all
with
end in
0
like
or 5.
0 or 5.
Yeah, so I go, oh, look, this is going to both be divisible by 5. And then maybe you remember how to do like long division. So I would say, oh, that's going to be 26. I'm just doing a little long division here, and this is
Mm-hmm.
91. And then I might look at them and go, oh, though both of those numbers divide by 13, and I've got 2 over 7. So that's one way. Another way that we can do this, and I'm going to pop out of here for a minute. Whoops, if my mouse will cooperate. Nope. There we go. Now it will. Okay. Are you seeing, whoops, are you seeing my Desmos screen now?
Mm-hmm. Yeah.
Yeah, okay. So the other way that we can do this is we can actually use Desmos, and we can just type in 130 over 455. Okay, and notice that it converts it to a decimal for me here.
Mm-hmm.
And if I want to see what that is as a simplified fraction, then I can pop right over to here, this little button here, and it will simplify it and write it as the simplified fraction.
That was like also another question I had. Like when we take the exams, like will we like are certain questions gonna be like do it by hand and then some are like calculate it? 'Cause, like,
No, there's nothing like that. It's your choice, and when you open up the exam, there'll be a link for Desmos, and then you can just click on that link and then make sure you leave it open so
mm-hmm.
that you can pop into it and out of it as you want. Um,
But
and then,
oh sorry.
sometimes like if it's a simple one and I can see something that divides out, I'm not going to waste my time going to Desmos. But for this one, it may not be immediately obvious. So this maybe is a good one to use for Desmos.
Um,
Pull this one back up so you can see the slideshow again.
yeah.
Okay, so there was our other way to do it. Okay. So, yeah, so if I'm simplifying a fraction, it just depends on what I'm doing. If I am near a computer and it's, pretty large numbers in the numerator and denominator, and I don't immediately see something, then I would probably use Desmos, or I might grab a calculator too. If it's small, I would, do the mental math. So
Mm-hmm.
it's nice to be able to know how to do all of them.
Yeah.
The next thing we're going to look at is a mixed number and an improper fraction. So do you remember these terms? A mixed number is just something like 3 and 4/5. And really, this is the
Yeah.
same as saying 3 plus 4/5. It's just shorthand. And so these numbers are nice, like, in the real world, if I'm going to like Home Depot and I need to buy a length of lumber, I might ask for 3 and 4/5 feet, and I probably wouldn't ask for 19/5 feet.
Yeah.
Yeah. So, but in math, we like this format, what we call an improper fraction. So it's equivalent to our mixed number, but what we've done is we've converted it and made this numerator equal to or larger than the denominator. And we call that an improper fraction. A proper fraction has a numerator that's smaller than the denominator. But these are really useful in a lot of math operations. So we want to know how to go back and forth.
Mm-hmm.
And to go from the mixed number to the improper fraction, we're going to multiply the denominator by whatever the whole integer is, and then add that numerator to the product. And then that becomes our new numerator, and we just keep the denominator. So what that looks like, if I'm doing something like this one, 3 and 4/5, is I'm going to take the whole number part, 3, multiply it by the denominator, add it to the numerator, and then I'm going to keep the denominator. So that's what that looks like.
Mm-hmm.
And then if I do my order of operations, which one would I do first?
The multiplication.
Yeah. So I would have 15 plus 4 over 5, which is 19 over 5. Mhm. Yep. And this one we can do using Desmos also.
Mhm.
I'll show you what that looks like. So for that one, we had 3 4/5. Okay. And Desmos wants me to put in that. Well, let's see if I do this, what it does. Yeah, it doesn't like it. So for it to know what I'm talking about, it wants that plus sign. Okay.
Oh,
And you can see that it converts it to a decimal. And if I
mhm.
want that improper fraction, again, I just click right here on this little fraction button. And now it writes the improper fraction for me. Oops, lost my annotate. There we go. All right. What about if I want to go the other way around? So I have an improper fraction and I want to convert it to a mixed number. So now I'm going to do division and I'm going to divide the denominator into the numerator. And I'm going to see how many times it goes in evenly. That's the new whole number part or the new whole integer part. And
Mhm.
then the remainder becomes the new denominator of the fraction, or sorry, numerator of the fractional part. So let's see what that looks like. Okay, so if we have 42/5, we're going to think divide 5 into 42. I like to use long division for this. And do you remember how many times 5 goes into 42?
I'm pretty confused because I have not done long division in like a long time, and I think that's where like I'm getting confused on this. So
Oh,
like I read over like the textbook and stuff, and like so it would be
mhm.
like 5 goes into like 40, like what is it like
Yes,
7 or 8 times, right?
yes. Yeah, and that's exactly how we would do long division. And then we would say, well, 5 times 8 is 40, like you said.
Mm-hmm.
And then we subtract and we've got a 2 left over. So that becomes the numerator and the 5 stays the denominator. So notice the denominator is not changing.
Yeah.
So 42/5 is 8 2/5. And again, this one I can do in Desmos. So again, as I'm working with more complex numbers, I might use Desmos a little bit more. So that was 42/5. So I can type 42/5. Okay. And notice that it's giving me it. Now this is a little bit, this has an extra step. Okay. This one, all I had to do was click on this, but this one, no, look what happens if I click on here, it gives me the improper fraction,
Yeah.
but I really want the whole number, right? Well, I know the whole number. The whole number is this 8.
You would subtract 8, right?
Yes. So if I subtract
Yeah.
8, I'm left with 0.4, which is 2/5.
Mm-hmm.
So I
Okay.
know that 42/5 is 8 2/5.
Mm-hmm.
So there's a little bit more logic and thought that goes into doing this one, but you can still use Desmos to do the harder part of the calculation.
What about like a bigger one? Like with like there was one on the homework. It was, let me find it one sec. Or it wasn't that big, but it was like 56/25. So
56
what I
over
do like
25?
yeah, so like what I do like 25 goes into 50 like 2 times,
Yes.
and then you'd subtract like 50 from 56, and you have like 6 as
6
your
25ths. Exactly.
okay. Okay.
Yes, you got it. Nice. Uh-huh. That's exactly how those are done. Beautiful. Okay, and then as we've kind of seen a little bit, I can convert between rational numbers and decimals. So if I have a rational number, I just do division. Remember that fraction bar just means division. So if I
Mhm.
have, let's see, let me get this back over here. Nope, I don't want to work that way. Here we go. So if I have something like 5/8, okay, remember this is just division, so I can think 5 divided by 8. And if I do the long division, then I'm dividing 5 into 8.
Mhm.
Nope, I'm dividing 8 into 5. So the 8 goes here and the 5 goes here. And then this is decimal, right? So I have to put a decimal here and then bring it on up and then plug in some extra zeros to help me out. So this one becomes a pretty big long division problem.
Yeah.
We'll do it and then we'll see how simple it is in Desmos. So 8 goes into 50. Let's see, 6
Like,
times?
yes.
Yeah.
50
And then,
remainder.
yeah. And then 6 times 8 is 48. And now we subtract. And 50 minus 48 leaves me 2. And then I'm going to bring down a 0. And now I just repeat that whole process. So now how many whole times does 8 go into 20?
Like, two, or,
Yes,
yeah, 2 times. 2 times.
2
260.
times. And 2 times 8 is 16. And then when I subtract 20 minus 16, I get 4.
4.
And I bring down another 0. And now it goes in evenly. 8 goes into 45 times, so I'm done. 5/8 is exactly equal to 0.625.
Okay. Yeah, I don't know. I
So
just
that's
like
how,
wanted to like I need to like know how to like do this stuff so it's good because I just want to know like I can do it like
yeah,
long division and stuff because I literally have not done it since like like elementary school.
right. They spend like a year on it and
Hmm.
then it just kind of goes away, even though
Yeah.
really to do fractions, you really have to use long division if you're
Yeah.
doing, pencil and paper or mental math. Um, but we can also do that one in Desmos. So if I do 5, remember this just means division, 5 divided by 8, so there it is,
Hmm.
0.625. So going in that direction is really simple. Going in the other direction is also fairly simple, except for there's usually another step.
Hmm.
So when you're going from a decimal to a fraction, what you want to first remember is that you're first going to look at how many places you have after the decimal. So notice here we have 1 place. So
Hmm.
these are tenths. This, if I write something like 0 point, I'm just going to write, okay. So these are tenths place, hundredths,
Hmm.
thousandths, 10,000ths, 100,000ths. Another way to think about this is for whether it's tenths, hundredths, whatever, the number of zeros is the same as the number of decimal places. So for
Hmm.
this one, this is tenths, and so I can write this as 7/10.
Okay.
The
Like
last
that.
digit go ahead.
I was talking about B. Like if that's a hundred, like that has a hundredth place, it'd be like 49 over 100.
Exactly. Yep.
Okay.
So I can always write a decimal with this as the numerator, whatever those digits are, and then the denominator is just a 1 with however many digits are that number of zeros. So this one would be,
1,000. So like
yeah,
it'd be 48 over 1,000, right?
exactly. And then this one I can, so these I can't simplify. 7 is a prime number and it doesn't divide into 10. 49 only has factors of 1, 7, and 49, and none of those divide into 100. But this one, I see right away that I can divide a 2 into both of them. And so I could divide 48 by 2 and 1000 by 2. What about 24 over 500? Do those have any common factors that you see?
Mm, like, mm, eight, not eight. Wait.
Mm. What about 2?
Oh yeah, two.
Yeah, and what does that give me?
12 and 250, right?
Mm-hmm. And then both of those are even also, so I can divide by 2 again. And now I've got 6 in my numerator and its only factors are 2 and 3, but 125 doesn't divide either though. So that's actually 6 over, so we're done. So sometimes we're done as soon as we rewrite it, and then other times we have to simplify.
Mm-hmm.
And again, we can do these in Desmos. We have 7, so we had 0.7 is 7/10, and we had 0.49 is 49 hundredths, and then we had, what was the last one, 0.048?
Yeah.
0.048, and we had, let me get rid of all this. We had 6 over 125. So we can also do it that way. Just have to click on the little fraction here.
Mm-hmm.
So again, as I have said, I like to, for this one, I like to know that it's just 7/10 because I don't want to have to click on Desmos to do that. But for, if I had something like 0.98734,712, oh, it's not going to tell me. I got too complicated. How about something like
Mm-hmm.
this one? Okay. So I kind of like that for that one. I don't have to do all of the long division myself.
Yeah.
Just kind of depends. Okay. All right. So that brings us to multiplying, which is the easiest operation when it comes to rational numbers, because to multiply, we just multiply numerators and we multiply denominators. So for this one, you're just going to think multiply numerators. So in the numerator, I have 2 times 9. And in the denominator, I have 3 times 4. And then I look to see if I can simplify that. Do you see a number that divides into both 18 and 12?
Two.
Yes. And what does that give me?
This one just give you 9 and 6.
Yeah. And is there another
Oh, this
number
could be
that,
divided by 3.
yeah. And what does that give me?
3 over 2.
Yeah. See why I like this better than making the factor trees? Because
Yeah.
it took us like 10 seconds to figure that out. I'd still be drawing out the factor tree. So it's just easier to kind of look for a common factor and keep
Mm-hmm.
dividing out, unless you have really large numbers.
Yeah.
The other thing that we can do that I love is before I multiply, okay, I'm going to be multiplying all of these together. So any factors in the numerator, in any numerator, can simplify with any factors in any denominator. So if I look at here, I've got a 3 and a 9, and they both have a 3 in common, right?
Yeah.
So I can, instead of waiting until I've done the problem and dividing out the 3 here, I can divide it out here. So 3 divided by 3 is 1, and 9 divided by 3 is 3. And then I look over here and I see, oh, these guys have a common factor of a 2. So I divide 2 into here and get 1, and 2 into here and get 2. And now my new numerator is going to be 1 times 3, which is 3. And my denominator is 1 times 2, which is 2. So I got the same answer. I just did the simplifying here. And as the numbers get bigger, it's so much easier to simplify these smaller numbers before, you might have really large numbers that you're multiplying, and then it's more work to simplify. So this technique makes the arithmetic a little bit easier.
Mm, yeah, that does. I think that's how I
Yeah.
remember doing it, like when I was a kid. Like that's how they
You
taught
do
us.
remember it?
Yeah, like they taught us
Yeah.
like cross multiplication.
Yes. Uh-huh. Cancel out any common factors. Yep. Okay. Dividing is also easy because to divide is the same as to multiply by what we call the reciprocal. So if you think about 3 divided by 2, that's like saying half of 3. So 3 times 1/2. And when I'm multiplying a whole number times a fraction, I can just rewrite it like this, 3 over 1, and then I can still multiply numerators, multiply denominators, and I have 3/2. So when I go to divide, what I'm going to do is rewrite it as a multiplication. So I change the division to a multiplication, and then dividing is the same as multiplying by the reciprocal, and the reciprocal is just when we switch the numerator and the denominator. So some people, I think, learn this keep, switch, flip. Because you keep the first fraction, you switch this to a multiplication, and then you flip this fraction. And the reason this works is because if you think about, here we had 1/2 and 2, what happens when I multiply those together? I get 1. And that's what I mean by a reciprocal. So reciprocal is just switching the numerator and the denominator. Does that one look
Wait,
familiar, maybe?
how do you get one?
Oh,
Okay,
when I multiply
uh-huh.
1/2 by 2 over 1?
Yeah.
Good question. I would get 1 times 2 over 2 times 1. And then
Oh,
I
then
can
2 divided by
simplify
2
that.
is 1. Oh,
Yes.
okay.
Yes. Any number divided by itself is 1. That's an important key of fractions. Yeah, that's a great question. Okay, let's see. All right, so 3/5 divided by, so I'm going to put it on the back screen, 3/5 divided so that we don't have to look at all that messiness. So we had, whoops, 3/5 divided by 7/11. So first write out the division problem, and then I'm going to rewrite it as a multiplication problem. I'm still working with 3/5, but instead of dividing by 7/11, I'm going to multiply by the reciprocal, which is the number that I get when I switch the numerator and the denominator. And now this is just multiplication. So 3 times 11 and 5 times 7.
Then
And that
you said
doesn't
40
simplify, so
or
I'm done.
oh, 35.
Yeah,
Okay.
33 over
That
35.
doesn't.
And you can also do problems like this in Desmos. So if you look at like, go back to here. So remember, the fraction bar is just division. So if I do 3/5 divided by 7/11, okay. Oops, I have the fraction bar in the wrong place. So if I want to do this one, I actually have to use parentheses. 3/5 divided by 7/11 so that I get the fraction bar in the right place. Otherwise, it's going to do the division in the wrong order. So this is going to tell it first do 3 divided by 5, then do 7 divided by 11, and then divide. And that way I get the right
Okay.
answer. So this one, it's really important. If I didn't do that, if I wrote it the way, the original way, 3 divided by 5 divided by 7 divided by 11, it's not going to do, you see, it didn't do them in that order.
Yeah. Oh yeah, that's
Yeah. It's first doing all of these bottom ones and then it's divide.
mhm.
So it's doing 5 divided by 7. It divides that by 11 and then it divides all of that into 3.
Okay.
So those, if you're going to use Desmos, make sure that you use the parentheses.
Parentheses.
Yeah. And then we have adding and subtracting. And if the denominators are the same, it's really easy.
Yeah.
Because if, and I always think about like slices of pizza, because I don't really like fruit pie. So
Mhm.
if I have a pizza and I cut it into 4 pieces, and this one I had 1 slice left over, and this one I had 2 slices left over, then in all I have 3 slices left over, and I've cut them up into slices of 4. So when I'm
Mhm.
adding, as long as the numerators are the same, I just add my sorry, as long as the denominators are the same, I'm going to add my numerators. And that works for subtraction. As long as the denominators are the same, I can subtract. So then the problem when I don't have identical denominators is how to get identical denominators, because once I get identical denominators, then I can apply this method. And the way that we do that is the reason we learned to come up with those least common multiples a few sections back.
Mhm.
Okay, so for these, we're just, like I said, we're just adding. So 3/7 plus 2/7 would be,
Wait, sorry, where are we? I was oh
I'm
3/7
looking
plus
at, yeah, I
2/7.
know, I'm sorry about these
Okay.
slides.
No,
Three
it's okay. I was just
sevenths,
writing. It's like
oh,
5/7, right?
yes. So
Okay.
this one will be 5/7, and then
So
this
they're like
one
the
would be,
same. 6/12.
yep. And then this one I could simplify, right?
Simplify. Make it like 2/4. And you can
Which
simplify that
is,
more, right? One and a
yeah,
half.
yeah.
Oh, okay.
That's good. Yeah, just keep going. You may not
Mhm.
see the biggest number that divides in right away, but if you keep going, you'll see it.
Yeah.
Now this one, remember I've got a negative sign here. And what do I do when I
Hmm.
subtract a negative?
Isn't it like addition, right?
Yes. So I'm going to change that to adding a positive 2 3/4.
Would
Mm.
you like make it an improper fraction or yeah, an
Yes.
improper fraction first?
Yes. So what improper fraction would this one be?
It would be like -20 plus 1, so -19 or
Oh, all of it's negative. So it's
mm-hmm.
going to be negative
Oh,
20. So
negative
it's -5 plus -5/4. Yeah.
would be so like if all of it's negative, does that mean like the negative like 4 is negative too? Like the whole fraction?
So just think of the whole thing as a negative number. So if I have -5 and
Mm-hmm.
1/4, that's like the opposite of 5 plus 1/4. Okay. And then to make this an improper fraction, like you said, 5 times 4 plus 1, so it's -21/4. Now, if they're both negative, do you remember that
Mm-hmm.
when we divide a negative by a negative, we get a positive, right?
Yeah.
So that means only one of them is negative. And that brings me to another kind of interesting point. For a fraction, I can write it with negative numerator over positive denominator. That's
Mm-hmm.
the same as having this a positive numerator and a negative denominator. And sometimes I write it with the negative sign out front. So these are all equivalent expressions for a
But
negative
then like the
improper
whole is like
fraction.
but like technically like the whole fraction itself is like negative.
That's correct. Yep.
Okay.
Because if I have something like -21 over -4, the negatives cancel. That's positive 21
Yeah,
over 4.
exactly.
Yeah.
That's why I'm a like with the original fraction, like the -5/1/4, like if the whole thing's negative, like wouldn't when you like multiply like the 4 times 5, like wouldn't that cancel out or no?
That makes sense that the equivalent improper fraction would be positive,
Yeah.
huh?
Yeah, like it's like yeah, it's just like if the whole thing's negative,
Yeah,
wouldn't
so, but would it make sense to say that -5 1/4 is positive 21/4?
no.
No, that means we have to keep the sign.
Okay. It's just like
Yeah.
a rule of like
Yeah,
a
so just
fraction.
think of it as like this. Think of there being imaginary parentheses there.
Okay.
So the whole thing is negative,
Yeah.
which is different than the numerator being negative. When the numerator's negative and the denominator's negative, the whole thing's positive.
Mhm. That makes
So if the
sense.
whole
The
thing's negative,
parentheses.
it means that either the numerator's negative or the
Mhm.
denominator's negative, or I can just write the negative sign out in front of the entire fraction like this.
That makes sense now with the parentheses.
Okay, good. And then, so this one would be,
That would be like oh wait, that's positive. So it would be
mhm.
8 + 3, like wait, why am I blinking? 11? 11 over
Yeah,
4?
exactly. Yes. Uh-huh. And so now my denominators are the same, so I'm going to keep that
Mm-hmm.
denominator. And then my numerator is going to be -21 plus 11.
So it'd still be negative, but like plus 11, so negative 10.
10. Then again, I can write it with the negative out front, and I can simplify 10 over 4, can I?
By 2.
Yeah. So -5/2. Mhm. Yeah, good. Very nice. Okay. Some good examples there. Okay, whoops. Back to here. Okay, so then when we have different denominators and we want to
Mm-hmm.
add or subtract, we're just going to get a common denominator. And remember, we don't have to do this to multiply. Sometimes people want to get a common denominator when they're multiplying. It's not wrong, but it introduces extra work that you don't need to
Yeah,
do.
that's what I kept doing on the homework. Like when
Ah,
I was multiplying and they were different, like I was doing that and like it was just like confusing me a
yes,
lot
don't need to
more
do
than
it. And you just made the problem harder because you have an extra multiplication to do at the beginning, and then at the end, you've got to simplify it again.
yeah.
So we don't want to do that. But when we're adding, we need that common denominator. So we find that least common denominator, which we did a few modules back, and then we write equivalent fractions. So what do we have here? 3/4 plus
Mm-hmm.
1/6. Okay, so I look at the denominators and I want the least common multiple of those two denominators.
There'd
You see,
be 2, right?
that's the greatest common factor. We want the least common multiple.
So is that when it like you have to like list out the like
Hmm.
multiples of it? So like
Yeah.
4. Why am I blanking
What,
on how to do it? It's like
so what I
4.
like to do is I like to start with the bigger number,
Okay.
which is 6. And then I ask myself, does the smaller number go into 6?
Mm-mm.
No. So then I go to the next multiple of 6, which would be 2 times 6, which is
12.
12. Does 4 go
And
into
2 times
12?
6. Yeah.
Yes. Done.
Oh.
Okay. Now what I want to do is I have to ask myself, what do I have to multiply 4 by in order to get a denominator of 12?
It'd be 3.
That's right. And then can I just randomly multiply the denominator? What else do I have to do?
Multiply the numerator.
Yes. Now it says though I'm multiplying by 1 because 3 over 3 is exactly 1.
Mm.
What am I going to multiply this denominator by? Yep. And again, I have to also multiply the numerator. And now I can simplify that. So I've got 3 times 3 is 9 over 4 times 3 is 12. And 1 times 2 is 2 over 6 times 2 is 12. Now I have a like denominator. So what do
Yeah.
I do?
You just add the numerators.
Add the numerators. 9 plus 2 is 11. Keep the denominator. 11 over 12.
Okay.
So find the least common multiple. Once you've found it, figure out what you have to multiply each denominator by in order to get that multiple as your new denominator. And then make sure you multiply numerator and denominator by the same number. Then we have common denominator and we can just add.
Mhm.
Ugh, okay, sorry, this one is,
Mhm.
let me rewrite that one. So I've got 1/2 cubed. I think that's minus 1/2 minus 3/4 squared minus 4. Okay. So order of operations,
Parentheses.
yes. So in the parentheses, I have 1/2 minus 3/4.
Mhm.
Let's come over here and work that 1/2 minus 3/4. What do I have to do to subtract these?
You just have like a common denominator, right?
Yes. So I need the least common multiple of
2 and 4.
2 and 4.
So like, can
So I
4
start,
be the denominator?
yes, it can
Just,
because I start with the bigger one, which is 4, and 2 divides into it, so I'm done.
yeah,
So I can leave this one. I don't even have to do anything here.
yeah. But you
What
just
do I have to
multiply
multiply? Say that
by
again?
2. So be you just have to multiply by 2, right? So just be 2
Yep.
over 4.
So 2/4 minus 3/4 gives me,
2 fourths minus 3/4.
mm-hmm. So I'm going to
Because you have to
subtract.
square it.
Let's
Oh,
just
you solve it
simplify this
first.
first.
Okay.
Yeah. What is
So it'll
that?
just
2
be
minus 3 over 4.
is that -1?
Yes, so -1/4. So yeah, let's just rewrite all of this with what we've
Mm-hmm.
done. Oops, that was -1/4. -1/4 squared minus 4. And now the next, so parentheses are done. Now I want to do the exponents. And you might want to just rewrite those as multiplications. So what does 1/2 cubed mean? It means we're going to multiply 3 times, right?
Yeah. So it just
And
be
then
1 times 1 times 1 should be 1 over 8.
1/8.
Or wait,
Mhm.
okay.
Yeah, that's right. And then this one, I'm subtracting -1/4 squared. So that's going to be -1/4 times -1/4.
Times -1/4. Or no, it's just squared. It's just squared.
So remember
So
the squared is negative. I'm squaring -1/4
mhm,
because of these parentheses.
yeah,
So I'm subtracting, and what I'm subtracting is -1/4 times -1/4, and a negative times a negative is a
positive.
positive. So I have +1 over 4 times 4, which is
1 over 16.
mhm. And then I
But
still
it
have this
stays
minus.
it
Say again?
stays negative. Like the negative sign outside the parentheses, like that keeps it negative, right? Because oh yeah,
Yes,
because it's only
I've got to keep that, don't I?
yeah.
Mhm. And now I need a common denominator again. So this time I want the LCM of
4 and
8
16. Oh,
and
8.
16.
Oh, okay.
So remember,
Oh,
this
because
is,
they're different. Yeah.
that's 4 over 1, right?
Oh.
So
So
it's
can't 8
always
and 16
helpful.
be? Oh, wait, sorry. What were you saying?
Oh, I was just saying it's always helpful to just rewrite this as a
Mm-hmm.
fraction just to remind you. So really, I
Okay.
want the LCM of 8, 16, and 1. And so I start with the biggest one.
16.
Does 8 go into 16?
Yeah,
And so
it's
does
9.
1, of course. So
Mm-hmm.
that's my least common multiple. And then what do I have to multiply 8 by in order to get 16?
2.
2.
And then you multiply 1 by 2 as well,
Mhm.
right?
Yep. So I have 2 over 16 minus 1 over 16. And then I have this minus 4. Now, there's a couple ways of looking at this. I could get a common denominator here. Yeah, actually, I probably should. So we'll just go ahead and do that. So what do I have to
Mm,
multiply 1 by? 16, right?
16.
So that gives me negative 4 times 16 is 64. Now I'm just going to simplify. So I have 2 minus 1
1.
minus 64.
That'd be negative 60 or negative 61.
So 2 minus 1 is
Oh, 1.
positive 1.
So
Positive
then
1
negative
minus
63.
negative 63 over 16. And I can't simplify that because 63 is 9 times 7 and 16 is 4 times
Mm.
4. So that's a good final answer. Unless it's asking me for a mixed number, but it doesn't say, it just says to simplify. So
So if it was like a mixed number, would you divide like 16 into 63? Like how many times 16 goes
I
into
would,
63?
yeah. And I know that my result's going to be negative. So I would just kind of
Yeah.
do this and I might start out here by sticking that out front. And I remember that I got 64 by doing 4 times 16. So this must go 3 times. And I'm going to multiply. So 3 times 6, 18, and carry your 1, and I get 48. And then what's left is 15. So negative 3 and 15/16 if I wanted a mixed
Mm.
number.
Wait, where did the 48 come from again?
Oh, I multiply 3 times 16.
Oh, okay. Okay. 3 times. Okay.
3 times 6 is 18, carry the 1. So 3 times
Mm.
1 is 3 plus 1, 48.
Okay.
Long multiplication, another thing we don't really do that much of
Okay. I just get like
after.
scared because I'm like on the exam, like I've had some problems where it was like without using a calculator, like do this problem. So
Oh,
like that's
in
what I
this
just get
class?
scared of. Yeah,
In what?
but I don't remember. I think it was like simple stuff, but not like with the fractions or anything. But
Oh, yeah. Mm-hmm. Yeah, I don't think there's anything like that on the exam. I'll have to look through it, but I can't think of anything where it would say, I mean, some things are certainly more straightforward to do without a
yeah,
calculator. But I don't recall there being anything that says, don't use a calculator. I think maybe in the section on estimation.
yeah, I think it
Yeah,
was like yeah, it was like an
because
earlier one.
yeah, so when we're estimating, like what's 19 plus 19, I can say, well, 19 is almost 20, so it would be practically 20 plus 20, which is 40, right? So the idea is to
Yeah.
not use the calculator and do 19 plus 19, but to estimate it. And so you're not gonna, if you try to use a calculator for a problem like that one, you're not gonna get the estimate that the test or whatever is looking for. So those would be the ones. Are you pretty confident with estimation?
Yeah, I am. I was just like, I feel like I like think about every possibility. So
Oh,
like when it came to this, I was like, oh, it's really easy for me to do on the calculator. But I was like, if there's like questions where like I can't use the calculator, like I need to know how to do them. Like
yes,
I don't know,
yes.
just
And I
like
mean,
that.
it's good to like I mean, I like to understand why things work instead of just,
Yeah,
punch it into something. Because the more you know, just the more information you have, the better decisions you can make. And
exactly.
sometimes one way is better than another.
Yeah, and you can like test your answers.
Yeah. Okay, so now we have what we call the density of rational numbers. And do you remember the number line?
Mm.
And like when we're first learning with the number line in elementary school, it looks like this. Whoops, I don't know why I skipped one. I don't know what I'm doing here. Okay, there we go. And then somewhere around middle school, they pulled out all these integers, right? And so forth. And then when we talk about rational numbers, we have all these numbers in between. So like halfway in between here and here is one, and I'm going to make that part bigger. So I'm going to make another number line that has 0 here and 1 here. And then, so right here we have 1/2. And then between 0 and a half, we have 1/4. And then 1/8 and so forth. And I can always keep getting closer and closer and closer. And that's a big theorem that we have in number theory that says if you take any two rational numbers, you can always find a number in between them. So we're not going to, this is not a, class for math majors, so we're not going to prove it or anything like that, but we're just going to kind of take a little look at like what that really means in terms of what we know from our class. So for example, if I have the numbers 1/2 and 3/4, how do I find, and there's kind of a simple way to find what's in between them. So here's 1/2 and here's 3/4, and I want to know what this number is. That's, well, I mean, it could be any number. I'm just going to find the number that's exactly halfway between them because that's the easiest one to find. And so the easiest way to do that is to just, instead of finding a common denominator, what I'm going to do is I'm going to make a new denominator for both of them just by multiplying them together. So 2 times 4 is 8. So I want my new denominator to be 8, which means I'm going to multiply this one by 4/4. And I'm going to multiply this one by what?
Is it, would you do two
I want to
or,
get 8.
oh yeah, two, and then for three
Yeah,
it's two.
yes.
Okay.
So this number is equivalent to 6/8.
Mm-hmm.
And this number is equivalent to
Four
4
over
over 8.
eight.
Yeah, so I'm going to write these up here, 4/8 and 6/8. And then you might see halfway between them would be,
Would it be,
what?
or wait, is it like 2/4 or,
How many eighths would it be? If this is 4/8
mm-hmm.
and this is 6/8, this must be
Oh, 5/8.
5/8. Uh-huh.
Oh.
Yep. So as long as we multiply this denominator by this denominator, so we're just multiplying the denominators together to get our new denominator, and we write those equivalent fractions, then we can always find a number in between that has the same denominator, but has a number in between them.
That's easier than what the textbook teaches us about this. Because they teach us to do like it's like I think you add them together and then you like multiply by 1/2
Oh,
or something.
yeah, I mean, that's a little bit more technical, but to me, this just makes sense.
Yeah, that does.
I like this way. But yeah, I know what you mean. They have a very technical way which is, you know, I think probably because it was written by a mathematician who knows the proof and is kind of
Yeah.
using elements of that. But if you, all you want to do is find the number in between, this is, I think, easier,
Yeah, that is easy.
more straightforward. I'm always looking
Mhm.
for, if there's a more straightforward way, show me and I'll do it that way.
Yeah.
And then we have, how are we doing on time? Oh, running out of time here. Um, and then, oops, I just also had a couple of problems that are, you know, like real world application type problems that you'll see in the homework. So,
Mhm.
I like to cook and to bake. And so I actually use this all the time. If I'm, you know, making a certain recipe that makes 12 servings and maybe I have a big group coming over, so I want to make 18 servings, or I have a small group coming over and I only want to make 4 servings. So you can always take the amount of the ingredient that's required and then multiply by the fraction of the amount of the recipe that you want, and you can change your recipe pretty easily.
Yeah.
So like in this example, we have chocolate chip cookies, and to make 5 dozen cookies, we need 3/4 a cup of sugar. So if I wanted to make 8 dozen cookies, how much sugar would I need? So what do you think about that problem?
Wouldn't you just like add 3/4 together like 3 times?
Well, so the recipe makes
Mm.
5 dozen, and I want 8 dozen. And so 3/4 cup is how much sugar I need for this. So the easiest way to think about this is if I want to take 5 and I want to multiply by something and end up with 8, I basically just have to multiply by 8 over 5. Then the 5s will cancel each other out and I'll get the 8 that I wanted.
Hmm.
Does that make sense?
That is a different way that like I'm learning the textbook too, but it seems so much simpler.
Oh, yes. Again, I think this is simpler. Yeah. So what I like to do is just think about the ratio of what I want to what the
Mhm.
recipe, that's basically what it is. A ratio of what I want to what the recipe is telling me. And if I multiply that by the amount, that will tell me how much I need.
So it would be, but would you like simplify it? So
I
I don't
would, yes,
remember.
very good. What would I simplify it to?
Like you could do like 2,
Hmm. Yes, I could
right?
even do 4, right?
Oh yeah, it'd be 6 over.
So 8 divided by 4 is,
Oh, 3. Oh no, wait, sorry. 8 divided
that's
by 4 is
okay.
2.
And then 4 divided by 2 or by 4 is
Well,
what?
is it 1? Okay, yeah, it's 1. I
Yeah.
was gonna say 0, but
Yeah, so I just have 3 times 2, which is 6, over 1 times 5, which is 5.
mm,
So 1 1/5 cups of sugar. And in the real world, when I do this, I don't know about you, but I don't have a 1/5 cup. So I kind of have to, you know, get that as close as I can using more fractions.
mm.
But for the purposes of the problem, that's all it's looking for. So yeah, just take, you're just going to multiply whatever the ingredient is by the fraction that represents the amount you want divided by the amount that the recipe is written for.
And then if you were like, if I had to do like long division for like that 6/5, it would be like how many, like I would it do like 5 divided by, or 6 divided by 5?
Yes, so like
That'd be how
this.
many times does 5 fit into 6?
Yep. And it goes in
like
once.
one,
And what's left over?
mm, five left
When I
over?
subtract here, I get 1.
Oh, okay, okay.
And then
Add a
I
zero?
could just write it as 1/5 and be
Uh-huh.
done. Or I could, if I wanted to do decimals, then I would add some zeros.
Okay.
But yeah, I can always write, let me just redo this. So 5 into 6, I can always divide, subtract, and then whatever's left over is my numerator of the fractional part. And this is the
Oh yeah.
denominator. Mhm.
Okay. That
And
makes
the
sense.
more you do those, you get to where you can look at it here and do some of the mental math. But when you're first reviewing it and doing it again, always
Mhm.
writing more is always helpful.
Yeah.
And I think if you have to go, that's okay. But I think I have one more
Oh no, yeah, you're
example.
fine. You can keep going.
Okay, I think I have one more. Oh no, I guess I didn't have. I guess that was the end of my examples.
I had the question about the homework though.
Yes, what was
It
that?
was okay, so it was like what which of the following is true about 1/6 plus 3/10? And the correct answer was the greatest common factor of the sum is 2. But I just
Oh,
wanted to know why.
so when I have a problem like this one, I think the best way to answer it is to just first pretend that you just want to know how you would
What it is,
simplify
yeah.
this. So what would be my least common denominator?
Wouldn't it be 2?
Um, so remember the least common multiple of 10 and
Mm-hmm.
6. I'm going to start with the bigger one,
Oh,
10.
okay, wait, yeah. Which I
So
get confused
does,
on. Like
yeah,
this, I need to
it's
review
okay.
my these common denominators and stuff.
Yeah.
The
So remember
divisors
when
or
I'm
whatever.
adding, usually at least one of these is going to get bigger if they're not equal.
Mm-hmm.
And when I'm simplifying, what's confusing is we have least common denominator, but the number is going to be bigger than at least one of them. And
Yeah.
then for greatest common factor, the number is going to be smaller than at least one of them.
Mm-hmm.
So I think that's what throws people off. But so if we just go back to thinking about take the bigger one, does 6 divide into it?
Mm-mm.
No. So the next one would be 2 times 10. Does 6 divide
20,
into it?
30.
Yes.
No.
So it's 30.
Wait, it does? Okay, yeah. Okay, yeah. So it's 30, yeah.
Yeah.
And that's 5.
S- Yes. So 6 times 5 and 1 times 5, which gives me 5 over 30. And here I need to multiply by
3.
3. And
So
I
it'd be
get
9 over 30.
9 over 30. And then when I add, I get
14 over 30.
mhm. And then when I simplify this, what can I divide numerator and denominator by?
2. Right?
2. Yep. And I get,
7 over 15.
yes. Okay, now what's the first choice of the multiple choices?
It was the the first choice was like the greatest common factor of the sum is 2, and then it was like we do not need to find the least common multiple of 6 and 10, and then 1/6 needs to be multiplied by 3 over 3, and then like the sum is 4/16 equals 1/4, which like I knew it was wrong, but I
Okay,
just didn't
good. So
understand
you could
why
rule out.
it was right. Yes.
Yeah, so what the thing says, the greatest common factor. So when we add
Mm-hmm.
it up and get to here, then
Mm-hmm.
the greatest
That's the
common
greatest
factor
common
is 2.
factor of them.